So what do I miss? I have everything in place, I think. What do I? Oh yeah, I need to press the record button. Right. So I might. Okay, right. So starting again. So quick introductions for anyone who hasn't been to my channel before or to this Twitch stream. My name is Armindo. I'm a software developer, and my channel is all about software development and Python programming. And I like to play with a Raspberry Pi, to be honest. So you'll see me a lot of times doing something on a Raspberry Pi. So right now I'm working on a long-term series where I'm actually building a wildlife camera with the Raspberry Pi, in this case 4, but you can also use a Raspberry Pi 3, not a problem, with a Picamera or anything better that I'll find along the way. And I'll do standard, OpenCV, which is a library created by Intel for machine vision, TensorFlow, which is developed by Google. It's now an open source project. You can actually do basically you can do object detection with this with the TensorFlow, and that's why I want to use TensorFlow. And who knows what else? There's plenty of other things I might use along the way. I think this is going to be a good learning experience for all of us, because I'm trying to record myself whenever I do anything on this project, so you basically understand. Okay, it might be a little bit boring because sometimes I'm actually doing stuff which is very much like setting up my development environment, or I don't know, creating a Docker container. It doesn't really have a lot into it, right? But it's good to know that these things are there. So if you want to become a software developer in the future, then you will be able to understand what it really entails, because it's not just the case that we're going to be doing cool stuff, and it's in general, like when you get to the point where you want to go, it's very cool, it's very exciting, but there's points along the way where it's actually quite difficult. You might find me sometimes searching on, well, you'll see me for sure, like Google searching for answers, looking at Stack Overflow whenever I get blocked, trying to resolve compile errors, who knows? Yeah, so that's the fun. Getting there is actually where the learning takes place. And when you get to the point where you really want to go, it's going to be very interesting, because I'm going to be using this wildlife camera. I'm going to place it in my garden. I'm going to have fun, because I have some wildlife. Even though I live in London, I do have wildlife. We have foxes coming sometimes to the garden. We have a wild cat. It's a kind of I think it's not like, how do I say? It's not like an African cat, but it's a wild cat, or like a feral cat at least. And he's quite fun. I've seen him a few times, and anyway, I'm quite curious because he doesn't look like a domestic cat. And what else we can do? I'm thinking of even doing time lapses with the camera. Who knows? It's so exciting. I think that once you know how to work with video and with TensorFlow, you have so much power. And I think the exciting thing is going to see what we can achieve. So for anyone who has joined in the stream, who is about to join while I'm doing my own development, don't hesitate, just say hi, and as soon as I see a message, I'll look at it and try to respond. I might not see it straight away, but if I do see it, I will respond. So without further ado, I think I'm just going to play the trailer again, because it's worth for you to watch it. I'm going to play that trailer. It's a bit cheesy, but you know, it gives you an idea of what I'm actually up to. And since you're going to see this on YouTube, at least you'll get a sense of what my channel is all about. And I have fun. I try to have fun and learn a lot. On the weekends, mainly, but So let's see where I'm trying to get to the right place. 1 second. Okay. Okay, here. Okay, this takes 2 minutes, so it's worth watching it. So hope you can hear the sound.
Every year, there are thousands of sightings of big cats across the country. Big cat sightings include jaguars, leopards, panthers, lynx, and even jungle cats. Big cats have been reported to kill cattle and even dogs. Till today, I didn't believe any of these stories. It's nothing more than a case of misidentification. Everything I thought I knew has changed today. I spotted a wild cat roaming in my garden. I managed to take a picture, but that is not enough to identify it. So, before I go on YouTube saying that I've seen a wild cat roaming in my back garden and make a fool of myself, I need to get extra proof. That is why today I'm starting a new series on how I built a wildlife camera with a Raspberry Pi, OpenCV, TensorFlow, and who knows what else. This is going to be an awesome camera, enough to capture this wild cat, dead or alive. Alive is possible. Just joking. Alive. Because the only picture I had doesn't prove that I have nothing more than a cat in my garden. It's not my problem. So join me in this journey to the unknown. We could potentially discover a new species of cat in the heart of the UK. And who knows what else we find lurking in the dark. What are you waiting for? Let's get started.
I promise you I wasn't drunk when I filmed this, but I had a lot of fun. So that's it. That's the key. So last week I had I spent quite a few hours trying to compile OpenCV on the Raspberry Pi, and I was able to get it done actually, but it took me a while. So by the time it actually ended up finishing the compilation, it took like 2 hours. Was my second or third try. I ended up having to finish the stream. So what we're going to do today, I didn't do any extra bit at all since last Saturday. I'm going to check what's going on with this. I'm going to log into the Raspberry Pi and see what happened. So bear with me while I actually log into the Raspberry Pi. So doing this. Okay, so I need to remove. Okay. So it's I have a problem with my computer fan, and one thing really worries me is that it's going to mess up the audio recording. So I need to just give you a little check. Okay, I hope the sound is good, because I'm running so many things, the actual laptop almost ends up frying. Okay, right. So, okay, no worries. So now I have my Raspberry Pi open. So let's see. I had compiled TensorFlow. Okay, I was actually developing in my local environment, so still have it here. What I need to do is switch on the Rsync again. I had an Rsync which was allowing me to make copy files automatically to the Raspberry Pi, so it saves me a lot of time in terms of, you know, because I want to do changes locally in my computer, and if I do changes locally, it goes straight away into the Raspberry Pi automatically without me copying it manually. So this is an important step, which I'm just going to, I have an alias somewhere. So, no, not here. I hope I saved this long terminal command. So projects, Raspberry Pi, TensorFlow. Not here. So let me look for the actual command line that I did. It was far too long for me to. Okay, I have it here. So this is already. If you want to know more about this Rsync, you can always go to my previous stream. It's on YouTube as well. In fact, you can know all about me trying to compile OpenCV. So I'm just going to run this. This creates an alias, and then what I need to do is whenever I want to start the synchronization, there's another command I have here, which basically calls the Rsync alias. And the Rsync alias has this really long Rsync command, and then fswatch is basically what it does, right? Whenever there's any file change in this directory or any subdirectory, it will actually call the Rsync Rsync command. So now I have something. I think I have a problem with my. There's some kind of invalid character here. So where is it? Oh, so when I was copying, I added some Raspberry Pi. I added some illegal character. Right, so now it should work. So the Rsync is set up. Okay, what I want to do is go into the Raspberry Pi, see what containers I have running. These are all created like in the last few days. Okay, so this is the camera. I have it running here, but the last time what I did was a build. So in fact I can call it again and it shouldn't be a problem because it already ran everything beforehand. So I have just going back to the Docker file. I should have OpenCV already installed, but I think there's one step I missed. From what I saw in the instructions, I need to actually, like, there was a website, PyImageSearch, which I was following. PyImageSearch, and it was telling me that I need to link a library from OpenCV, which is a Python library with Python. Otherwise, it will not work. So I didn't do that step yet because I wasn't sure exactly how to make it to add it to the Docker file. So I need to actually have a look. So first of all, I'm going to go inside the container and I'll see what's inside. And based on that, I will kind of add something to the Docker file. So I've done most of the steps here. So the last one is step number 6. Step number 7 would be to test. We can do that later. So this is assuming I'm using a virtual environment, but I'm not. I'm using Docker. But the step in this step should still apply. If I want to go inside the container, I can just do docker exec -it. I'm just going to do a clear so I don't know how to. Just check it, everything is visible. I don't think. Okay. Okay, it's easier, right? So now you'll be able to see everything. So I'm inside the container already, but just for you to see. I need to clean up some files later on. Going back to the instructions. So I need to find where OpenCV was installed. Don't even remember if it's in the same place or not. So it seems like I haven't copied yet. I thought I did. This Docker file, make install. Don't know. Oh, I think I haven't done a crucial step, which was I need to stop and start. Okay, so because I only built the actual Docker container. So down to stop, then up to start. I've already done build, so I don't need to do it. You only do build whenever you change the Docker file. So now I should see all the files as they are in the latest container. Oh, I know what I did wrong. I should do a -d to basically allow it to run as a daemon. If you make it run as a daemon, then you don't have to wait forever for the command to end. So I can just check if it's running. In fact, I can do this. Since I have so many Docker containers, it's hard to see what's actually running. No, I thought I had that. No, the same thing. You can do ps -a. So I can see the camera container is running. So I can just go inside again. So let's see if I have any OpenCV now. Hopefully it's already copied to the right place. Yeah. Let's see, maybe if I'm lucky, it's already done what it's supposed to do. So I don't have to do it manually. Because if it already has a directory with the OpenCV library, that means... No, that's not what I was expecting. So this is the library that I was talking about, but this is already inside Python. So it's telling me to go to the OpenCV site package. Okay, you know what? Let's just do one thing. I'm going to do this test first. We should fail if something is wrong, right? So I'm just going to do that. So Python. Let me check if the default is the one I want. Okay, so I'll just run this and it will allow me to test, to do the import CV2, and if the actual library is not there, it will fail. And because if it's already working, I don't have to do anything. Simple. Even though it says it's very important, it seems to work. So if it seems to work, I think I'm done. Yeah. The only thing I could do maybe is clean up this. Maybe I can clean up this build directory. I hope it's not needed, but even if it was. Okay, let's do this. So I'm trying it inside. Delete everything. You don't have to worry because it's already in the Docker container image. So it doesn't get lost. So let me just try again the same test I did just now. Import CV2. Yeah, still there, right? 4.5.0, that's the latest version of CV2. So now I know I have OpenCV2, and I'm just going to do one last cleanup on my Docker file, which is important. So I'm going to just do run so root something like this. Just checking that. And this should clean up quite nicely. Let's try it. So as I said, I'm doing the sync to the Raspberry Pi, so I can go into the Raspberry Pi build. Let's try it, see if it works. It's supposed to work. Obviously it didn't. So let's see what's wrong with our Rsync. What's going on? So it doesn't seem to be synchronizing. Okay, so what I can do is just force it to save and see what happens here. It does seem to recognize the file. I wonder if it's again doing okay. It's the last time I had corrected this, but it seems like I forgot to update the command. You know, it's connecting to the wrong directory, and that's because of my rsync. So I need to. So if we look at here, so just make it a bit bigger. So I don't need to include this directory because it will already created. It will basically use the other directory as a base directory. I'm sure there's another way of doing that, but this is the easiest. So I'm just going to change my rsync again. I want to be sure that I don't copy again the illegal character I did last time. And then let's see if it works now. Okay, now I can see my new rm command. I'm hoping I can do rm for 2 folders at the same time. I don't remember 100%. Let's try it. still have this annoying issue with having to add sudo to the docker command. Okay, so it seems like it ran my rm command. So I'm just going to take the other container down and start it again. Okay. And that's it. So now I have a clean, I say I have a clean, but it doesn't. Oh, it didn't delete everything. What happened there? It deleted something. Yeah, .zip. Okay. You know what? There's a saying. It's kind of nice to have. I think the issue is not that I'm trying to do two things at the same time. It's just so this wildcard might be the issue actually. It works fine in the bash, but when you're on outside bash, let's see. Make sure it's changing. Come on. Okay, obviously it didn't work. Oh, because I didn't stop the container and it started again. All right, so now it should be okay. Let's see if it did anything. Okay, it did delete something. I think it didn't delete everything because I need to change the work directory. But you know what? I don't necessarily have to spend more time trying to fix this. But well, this is kind of the tidying up to make sure things are done properly. So I'm just going to do one more time, even though I'm saying I don't want to do any more, but I'm doing it. And then down. And then up. there's no artifacts and nothing that I left over. OpenCV is installed. One more test just to confirm again. Import CV2. And then what was the actual CV2 dot? Yeah, so it's installed, the OpenCV 4.5.0, Python 3, then we also have already TensorFlow. I think the last thing I need to do, sorry, I always think I'm done, but I would want to push this into a Docker Hub. Because it takes a long time to basically get this actually running. I'm going to make sure I save this into GitHub first. Wait, don't want this to go in. Oh, I see, I need to... What's going on? I need to make sure this project is set up correctly. So I'll do that later. But I know in the Raspberry Pi, it's all good. I have the key correctly set up. Just have to make sure I do it this. Okay. Right, so now I've saved in GitHub at least, but I still need to log into Docker Hub. So I need to do this in a separate window, sorry. I don't even remember. Oh, it doesn't have to. Okay. So I'm logged into Docker. So you just have to. So I'm going to create another. Just to have to do this. So I'm just going to Docker to basically, I'm going to Docker Hub to create a new container that I can basically share with everyone. So I have one for TensorFlow alone, and I wanted to have one for TensorFlow and OpenCV for anyone who wants both. I leave this one here because it might be that someone needs it only with TensorFlow. So. What's the name? Okay, so now we have what happened there? I can even connect this to okay. I can try and connect it to GitHub, but only thing I'm not 100% sure is that whether it can compile anything in ARM. That's my problem. So each operating system will have separate images. So I don't want to risk it. I'll do the build myself. So all I have to do is follow the instructions here. There was one second. So this one I want. Okay. I'm just going to copy that to my notes so I don't forget. So I know this is the, let's see. I'm going to make it latest. So actually, maybe this isn't a bit nicer. So I'm going to give this a tag. So this is version TensorFlow 2.3, and this is OpenCV 4.5.0. And I need to, so basically I'm going to find out what was the tag name I used in the first place. So this is a tag. The image name, I think that's it. Docker tag. And then let's just give it this name. And now I do a push. Can you see that? Just okay. Just be making this smaller, not. Okay, so this is the command. And I'm just going to run it. So it's going to take some time to, what? I thought I logged in just now. I thought I logged in. Just going to confirm that again. Oh, I see. Oh, sorry, I need to go and get the password. Again, having to go to a separate window. Sorry about that. I think I made a mistake, sorry. Just giving me access to now. I missed something. Okay, I was missing something fundamental. Okay, it's now doing it. I'm pushing now. It will take some time. It's going to be on Docker Hub. Let's just do. So I'm finished with the setting up OpenCV, and now it's going to be saved in Docker Hub. So I'm all done. This will take a while, but I'm not going to bother you with this. So I'm going to I'm just going to check if I have any messages. Okay, I'm going to finish the live stream for now, and I'm going to come back and do a little bit more. So I'll be like, so now I have TensorFlow, OpenCV. We can just maybe give it a try and see if we can do anything with OpenCV just to warm up. So for now, it will be all. So I'll speak to you soon. Bye bye. Right, so I'm back. I'm still waiting for Docker to push the new container, but while I'm waiting, actually, I think we should be doing something with OpenCV, just to try and get a little bit of that tension, you know, when you actually don't try something for too long, you only, you know, you're only doing development, and if you're only doing if you don't see anything running, you don't really have that confidence that something is going to work eventually. So I think we need that confidence right now. So I'm just going to see how I can, actually, I have, first of all, I could start the camera in, so let me just think of how I'm going to do this. I can't do much while this is running. Could do something on my own laptop. So just let me set up everything, make sure everything is right. Okay, while I'm waiting for it, so let's see. So let's do a Raspberry Pi OpenCV quick start. Let's see what we can find in terms of, I want something very simple to start with. Example. So I'm doing from scratch. So I always end up in this website, pyimagesearch.com. It has a lot of really good information about Python and OpenCV. Adrian Rosebrook is someone I actually have followed for a while. He has some excellent articles, and I think he's also done a couple of YouTube videos, a few, and you might want to check his channel out as well, because it's very useful. So I'm going to, so he's done all this before. All I want is really some started code that I can just use as my starting point, and we can start getting that ready while we do the Docker container. So I'm going to call it, I'm going to create a folder called Python. The only problem I see, the way we are doing this, we're not going to have a lot of, if we're running in Docker, it's good for seeing code that actually is supposed to run in the background, but it's not very good for code that actually needs to show any like windows or anything like that. So I might actually want, we'll see, I'll have to figure that out, because I spent so much time setting up OpenCV in Docker. I'm not going to start doing the same thing outside Docker. It makes no sense. But let's just create a file, example.py. I need to have access to the Picamera libraries as well. And I remember now a step I need to do, which is I need to somehow set up a volume to share the Picamera API. Okay. So Docker Raspberry Pi Camera API share. This is the important one. Okay, I need to do something like this. So I need to share this folder. It's in the Raspberry Pi, and I need to share it in the same location inside the Docker container. So I don't need to install the libraries. They're already there. So I don't need to install them in the Docker container itself. Okay, so let me just try this. First of all, check if we have that directory, and I just have to go to the Docker Compose, set up here a new share for volumes. Okay, so once our Docker container is pushed into Docker Hub, we can try this out. I'm not going to risk much until then, but okay, anyway, this is one of the steps. This is a syntax in the Docker Compose that allows me to basically say, okay, I can share any folders from the host machine, in this case the Raspberry Pi, with the actual container itself. So I'm just mapping. So I could have put this directory in a different place, but it is not convenient. So anyway, this is one of the steps I needed to follow. So it's telling me to also do this, set up an environment variable. So let me do that as well. So environment, something like this. Can't remember 100% if this I don't know for sure if this syntax works, but I have a rough memory, so if something goes wrong, then I'll just fix this. But this is roughly what we need. And then, so this website, I should put this as a reference for later, if I forget it. And I can give you a copy of this as well. Okay. So let's see if there's anything else we need to do. So here, now that we have permission to access the camera device and all required dependencies, we can use the camera to capture images. To access the camera using Python, the Docker container requires a Picamera module to be installed. Building a Docker container is outside the scope of this article. I've done it. However, the following is an example Docker file that will result in a Python container with Picamera installed. So I still need to install this library here. Okay, this is good to know. So I need to install pip3 is for Python 3. So I'm installing the Picamera module. which is a Python wrapper, a library wrapper for the actual library, which is written in C, I think. So this is just a Python wrapper. And then I could change the command. For now, I'm just going to leave it as it is. I'm going to run it manually. So the only issue I see here is that I'm not going to have this is all going to be like in the background, right? Okay, this is finished. Thank God. Okay. Right, so since it's finished, I can do a build again of this. So it's going to install the library. Well, it will try, be failed. Don't know why. The easiest is to go inside and see what's going on. Oh. Wonder if it needs the actual libraries to be there already. Oh. Okay, let's see. We might have an issue here because it detects as a not a Raspberry Pi and it fails. Okay, what I'm going to do is I want to just try manually from inside once the actual Raspberry Pi files are shared and see what happens. I hope I can fool it to think it's a Raspberry Pi. It is in a way. Failed, but it doesn't tell me why. Okay, it does still not happy. It's not happy that it's not a Raspberry Pi. Let's see if there was on anyone facing the same issue. Maybe there's a way to force the library to be installed. It's old. So I'm hoping someone tried to do the same thing as me. I hope it doesn't mean I have to do everything again. It seems like he uses another image as a starting point. It does a check to see if it's a Raspberry Pi or not, and maybe there is a variable that allows me to switch that off. Use this Raspberry Pi container. Let's try this and see if this actually works. I have no idea. This seems to be too good to be true, but you never know. Why would the read the docs equal to true make any difference? If it does, I'll be very surprised. Wow. Read the docs equal to true. I've read the docs, okay, so it works fine. But I shouldn't laugh too much because this is just installing a library. It doesn't mean it actually works. So let's see. Okay, so exit. Let's hope it works. Okay. If I have the Picamera installed, there's a good chance it might work. Okay, so going back to that guide, I got lost. Where I was. So thank God I've actually saved the URL. So let's see. What I can do now is just copy and paste this and hope I hit the jackpot. So let's see here. I've already copied it actually. But you know what? I don't want to spend a whole lifetime copying files. I'm just going to try this inside. in fact, I could just mount the volume from the Raspberry Pi straight into the container, and this way I can change things straight away and see the changes immediately. I'll do that later when I start actually doing more things. So right now I just want to do a very simple test just to make sure that I don't even have VI. Nano. Okay. This is definitely only once. I'm not doing this every single time. Install VI. Sometimes it's yum, sometimes apt-get, depending on what containers or what Linux flavor you're using. So I've installed VI, so I can just create a very simple Python script. Oh, this would be such a big win that if I can actually, I know it will not work for a simple reason. I haven't given any privileged access to the Raspberry Pi camera to the Docker container, so I need to do that. But it's good to watch it fail first. What's that? Fail to open V8. Okay. Before I even try to figure out what that is, I'm going to have to do something very important. Privilege. Okay. I'm surprised it doesn't mention it here. Okay, there's a device. Okay. Let me just see. So let's, I think I might want to read this from start to finish, except for the first paragraph. So this tutorial is perfect. It tells me how to access a Raspberry Pi camera from inside the Docker container, which is what I want to do. And here, more importantly, how to let non-root users access the Raspberry Pi camera. I don't want to always have to use root. The Raspberry Pi camera is treated like any other Linux device which is attached. When it is attached, it is mounted at dev VCHIQ, which is the device we tried to. This is from the error message. With the base installation of Raspbian, the camera device is only accessible by the Pi user and the root user. Since Docker containers have their own set of users, any attempt to use the camera will be met with an access denied error. Let's first start by understanding why the camera is only accessible by the Pi and root users. He's very scientific. Okay, it's good. Linux uses a system called UDEV for device management. Among many other tasks, UDEV has a set of rules that apply permissions whenever a device is attached. Raspbian comes with a UDEV rule for the camera which can be viewed at this directory. Let's see. Let me just have a look at in a terminal. I have to exit. The file, so I can just take a look. There is some stuff here. And the root user will always have access to any Linux device, but the rules shown above are granting read and write access to any user in the video group. I see where this is going. Since the Pi user is a member of the video group, it also has access to this camera. In Raspbian and most other Debian-based Linux distribution, the built-in UDEV rules are located in this place. These rules can be changed, however UDEV does allow to add additional rules in here. In order to grant all users access to the Raspberry Pi camera, create the following file. Let's create this. So this is actually outside the Docker container. This is important to to remember. I'm documenting it here, which is good. Later on I will remember that. And then I just have to copy these. Oops. Oops. Okay, so I'm just saving this. So this is going to give access to this device to all the users. Nice. Okay, I need to do sudo. Okay. Okay, so now just save and exit. It's common practice to prefix udev rules with a number, so that's why we've done the 99 here. This is because udev rules are executed in alphabetical order, and using a number prefix allows us to control that order. And we are using 99 because we want the built-in rules to execute before our custom rule. So our custom rule should be last. That's why he put 99. So we don't specify a group, which means that all the users can access outside the group. And then the mode is, we change the mode so we give permissions to everyone, which is fine. So we need to pass in this flag, device, and so on. So I need to figure out how to do this in Docker Compose. What I've seen before is just give privilege like permissions to everyone, and then you can just access whatever you want. But it seems like this is a more fine-grained control. So new tab to the right. What did I just want to do? I forgot. I want to do more searching. Docker Compose device. So this is I mean, because I'm not calling the Docker command directly, I'm using Docker Compose. I need to figure out the syntax in the YAML to do the same thing as I would if I was calling the Docker command directly. And it's here. There's a mapping. Okay. So I'm going to try oops. Have to make sure the YAML is aligned. But this is not the actual device I want. So I need to go and copy again. This one. So the question is, do I need to map it? Here it's implying that I need to. So I'm just going to map it to the same place, but I suspect if I didn't specify where to, it would be the same as doing it like this. But I need to double check. I'm just saying that. But I'm in no mood to make this fail straight away, so I want to make it work first if I can. And if it works, then maybe I'll just be adventurous and I'll see if the syntax is okay like that. Oh, I don't need to do a build because I'm only doing a Docker Compose. I'm changing the Docker Compose YAML file. I just need to stop the container and start it again. Which means my file is going to be lost. and even vi. So maybe I should do something about it, right? So let me just do one thing, right? So I have a Python folder which has my example, and I want to be able to run this inside the Docker container without having to build a Docker container every single time. I also don't want to restart. Yeah, so the way to do it, I can just map another volume. So in this case, /Python, and I can, let's call it, let's call it app. So I'm going to mount Python to the app directory inside the container. And now I'm just going to stop this again. And then I'll start it again. So when I go inside the container, I should see a file already inside the app folder. So here, so I have my example.py, which has more or less what I want. Okay, so I'm just going to run this. See what happens, blow it up. I don't necessarily expect it to work straight away, but I was hoping. So fail to create. Okay, I'm not 100% sure what this error is about now, but okay, so let's see what is the, hopefully someone already had this error and this could tell me. So, what it didn't tell me here is if I have to restart something. I'm going to try and add privileged. This is the right place. So let's try again. Okay. This is a different error, because this example is trying to show something on the screen. It's not exactly the example I thought I was trying to run, but it's anyway, I can figure this out. If I can actually show a window here, that would be great, because then we can do a lot of testing. But let's just first get that example working. I'm getting close. I might have missed a step here, but you know, if privilege gives me what I want, I'm happy with that. I'll take it as a win, you know. I think the author is very careful not to give like all the permissions to the Docker container, because that could be a security risk. But we're doing just a prototype right now. Okay, so I'm just going to create another example so I can use this one later. So example.py. Yeah, so let's see what it gives me. Oh, this is nice. Oh, so the only issue I have is that I can't see. Oh, I can. That's the nice thing about mapping directories. No. Okay, so I can just go into the Raspberry Pi. Let's see. What was the directory again? This one. Just check. There's output.jpg. You're going to see a horrible image because I have my lights are switched off. But you know, it's huge. So the camera itself is pointed towards like the wall. Right now it doesn't matter, right? But this is it. We've got OpenCV and we have Python, and we are able to access the camera. I don't think I haven't used OpenCV yet, but this is just a start, trust me. So this is good. Take the wins. So what else? I almost want to call it a day, because you know, you want to finish on a win. But it's not over yet, so I wanted to see if there is any way to just to make our life easier, because it's I know I'm using Docker. Docker is kind of, it gives me some things and it takes things away. And one of the things that is annoying is that if you want to run anything like that has a graphical user interface, like xclock, I don't know if I have that installed here, but it will not show. So for sure someone on the internet has figured out, and I'm just going to take advantage of that. So opening window. Okay, just simple. So you don't want to confuse with Windows. Graphical X11. So I want, it's the same as, I think this is a one example. I want to open a, okay, the TK library is exactly the error I was getting. So TK requires the display to work, and the Python container I'm using doesn't have a command line interface. Okay, so one option is to, but hang on, this is for the Raspberry Pi, right? So why do you install Xquartz here? But I think what he has done is he diverted the display to the Mac. Don't like that. I'll rather do it on a Raspberry Pi because I already have a Raspberry Pi. So it's doing, it's mapping I don't share the laptop screen. I want the Raspberry Pi, come on. You just give me hope. Okay, I'll keep this in mind, just in case he's the only one who tried to do this. Okay, so this is a bit more promising. Okay, so sometimes as a sysadmin or a developer, you have to run some Docker, some GUI-based application in computers that are not yours, or simply run it as first run. Okay, I don't know what to say. This noise comes. So okay. So it's mapping. So it's mapping the local directory for X11. That's there. Okay, I'm going to hope that this works. I'm going to add it to the Docker Compose. In the bonus section. Okay, so I'm mapping this directory to the local directory in the Raspberry Pi in the Docker container, and then I need to do that environment variable, and this is just to set the display to whatever I want it to be. This is going to take the display from the local. Just going to keep that. This is a good guide, but I'm not happy that it's not specific to the Raspberry Pi, and I don't want to be guessing too much, so I'm going to search a little bit more and see if I have something. So it's exporting display. Just wanted to figure out. Okay, seems to be copying it. Not sure. Okay, the actual error I'm getting here is not even about the accessing the graphical user interface. It's even more fundamental than that. It doesn't have support for GTK. But I want to just see if that works first. I'm just installing a simple X11 app so I can figure out if the graphical user interface would work anyway, before I even spend a lot of time recompiling OpenCV, which is, to be honest, I don't think I want to do that right now. I think OpenCV has different ways to open Windows, so I might just be able to change that. Okay, at least we know it's not working. Okay, just going to recycle something. This is like anyway, I've managed to access the Picamera with the Python. That's a big win. I'm just trying to go one step further so that I can make it easier for myself later on. I just want to figure this out. I'm starting to see with good eyes that the tutorial I saw. Maybe it's not such a bad idea. See if I know I can. Can try and do. Okay, let me see. I can connect to the Raspberry Pi from inside the container, so I could try and do something like, I don't know, could this work? Can't open display. not working. Wait, I made a mistake. So inside the container, let's see if I can ping this IP address. I can. So you just try and set the display like this. Let's see. not really telling me. Let me try from my own laptop. Oh no, it's the opposite, right? Let's see. Just wondering if there is a port. Maybe it's has a firewall. So this is a little bit more tricky, but what I'm trying to figure out is if there is any networking I need to do to be able to make this work. already there. Okay, so I see. So I don't need to, because I'm running as network host mode, I don't need to say, I don't need to use the IP address. So this should actually work, but it doesn't, right? Oh no. I just had a quick way. Oh man. Sorry, yes, sorry for the high level of enthusiasm. So I see my stream is getting a bit dark. 1 second. Getting dark over time. Okay. So I just managed to open something from my Docker container in the desktop itself. So that's good. Okay, it doesn't solve my problem completely because I know there's a library I'm missing and I don't really feel like installing it because it means I have to recompile OpenCV, but I think OpenCV allows you to change your the way you display stuff. I really don't want to reinstall this, but I've solved. I might have to do it, but I'm just going to double check that there's no other way. But I'm very close. Okay, let me just put this on Raspberry Pi. Nice, no help. So, right, and so I'm getting the same error as this. Ooh. It's like, okay, so it doesn't have any help. I just want to see what I should do. Okay, so it's good to know even if you install those two packages and OpenCV is recompiled, it doesn't work. That doesn't help me. I'm sure you solved it at some point. Excuse me. This seems to be so obscure. It's almost not a good idea to try and get into this. Okay. So if I understand well, I need to install this library, and then I have to recompile OpenCV, and that will take forever. I might have to basically do again what I did last time. I'm going to execute it, run it, and I'm going to go offline, and I'll finish the stream. But I think we've done a lot. We've already managed to access the Picamera from the Docker container. I even managed to open a window from the Docker container, like an xclock, which was the thing I used to test. So I need to also make sure I have this right. OpenCV. This is an old error. So it already has GTK on. So it should be a question of just but I'm going to add this to the Docker file. Okay. So it's already installed. So I just need to install, I need to add this. Okay. probably smart to do here. Okay, and I'm adding it here because I have no choice other than compiling all of this again. Right? So this is going to take forever. But we have no choice. So I'm going to let it run. So so it's going to take a while, but we've done a very good progress today. This is from last time I took a picture, and then we had, so I was able to take actually a picture, and you can see the proof here. So next time I'm assuming that OpenCV will actually be able to open a window, and in that way we'll be able to play around with the OpenCV and just do some experiments, and that's going to be really useful. So I can see, because we are developing right now, so we want to see in real time if we can any kind of changes, you know, what effects our changes have. Yeah. This is the painful part of developing, setting up packages, libraries, getting things to actually work. Sometimes it can get quite tricky. And that's why I'm actually recording all of these and sharing with you, because you'll probably try and do the same, and you can just follow me along and we'll get there. All right. Thank you so much. I think I'm going to log off now, and I'll be back again next Saturday, roughly at the same time. Yeah, so thank you for joining us, and see you again soon. Happy coding!